But the first thing I want you to look at is the title of what it's asking you to use. Tells you a lot, right? So when we solved by substitution, we did a whole lot of substituting, right? Okay? When we solve by elimination, we're going to do a whole lot of eliminating, okay? So let's kind of start with, and eliminate means to totally get rid of, right? So think about if you've ever played in a tournament where it's a single elimination tournament. You lose, you're out, right? Okay? So we're going to talk about what a level 1 means, and we already know what level 1 means. It's the easiest level. It's a video game level that everybody can beat. It's all ready for you to go. So this is what a level 1 elimination system of equations looks like. Okay? So I want you to think about something that you probably would never in a million years think to do this, but it's a whole new way of learning something. So you know how when you learn like how to add, addition facts, you could learn it horizontally or you could learn it vertically. And when you learned it vertically, you drew like a plus sign and a line under it. And maybe you got into double digit, and maybe even got fancy and you added these two together and you carried it over your 10, right? You added this row with this row and this row with this row. Well, guess what? That's what we're doing for elimination. We're going to add not a number. We're going to add not even an expression. We're going to add this equation to this equation. And in the meantime, something's going to get eliminated. And if it's not already set up, your goal is to make it so that it does eliminate. So we call this a level 1 because everything is perfect, right? So first of all, what form do you notice that both of these are in? We've learned the names of these forms. It's not slope-intercept, it's standard, right? So the first thing I need you to know, it must be in standard form. Okay? And it's a level 1 because it already is. Do you think you're going to get problems where it's not in standard form? Yeah. How are you going to fix it? Put it in standard form. And I've taught you how to do that. Okay? And what else makes it a level 1? It's already set up to cancel. Meaning I'm looking to totally get rid of a variable. I need to either totally eliminate the x's or totally eliminate the y's. And in this case, when I go to add my positive 2x and my negative 2x, it already is ready, okay? So you need to have it set up for at least one of the variables, one of the sets of variables, to cancel. Okay, and we say cancel out, but you want to eliminate one of them. Okay, that's why they call it that. So now, once I eliminate my x's, watch how easy this is. Oh my gosh, go ahead and add your y's. Go ahead and add your constants. And now you just have to solve for y. So divide by 8, and what is y? 3. Okay, so I figured out that y is 3. I put it in the right spot. Evan, why don't you hop to the other side of the table so that you can see easier? Okay, thank you. So now that I know that y is 3, guess what the beautiful part about solving systems is? From here, it's the exact same process as yesterday with substitution. Once you know one, you go and find the other. However, it's a little bit more work because both of these equations are in standard form, which means now when I put the y in either here or here, I have to multiply by 3, then I have to cancel that out, then I have to divide by 2, whatever, it's not horrible. So I'm going to say 2x plus 3 times y equals 11, and my y ended up being 3. And so this is why you are masters in equations, because you have got to use equations a lot. Solving equations is a must in algebra because you use it a lot. So now that I know that y was 3, I find out that my x is 1. Okay? If I were to just say x minus y equals 2 and x plus y equals 10, try it. Christian, if you need a mechanical pencil, if that's not working, let me know. Okay, so try that one. It's a level 1. It is ready to go. They're in standard form. One of the two variables is ready to go. What should I eliminate?
Sorry, but up there, when you were solving for x, where did you put the 2x in the equation from?
I use the top equation.
Okay.
Yeah, you could use either of the two equations. So I just use this one. Yeah. Good? Okay, my y's are gone. 1x plus 1x is? And 2 plus 10. Look how easy level 1 elimination is. Okay, x is 6. And so now you use that 6 to find the other missing piece of your answer, and you're going to plug it in. Okay, now, which one would you plug it in for? The first or the second equation? There is one that's easier. The second. Why? Because the y is positive. So when I go ahead and subtract it, I don't have to divide by a -1. Are you starting to see? You're going to be, picking easier answers. So if I put it here, if I put 6 plus y is equal to 10, all I do is subtract 6 and I get my answer. If I chose this one, again, this is a perfect example. If you choose the top one, are you wrong? No. It's just like walking to school instead of hopping in the car and getting a ride. You're going to get there. It's just going to be a little extra work and take a little extra time. That's it. So it would have worked. So 6, 4. Level 1. We moving on? Okay, so what makes a level 2 be a level 2? One or both of these things is not true. Oh my God, I just sounded like Dr. Seuss. I just rhymed. Don't ask me to remember it. Level 2, we read a lot of Dr. Seuss at our house. So 4x plus 3y equals positive 2. 5x plus 3y equals negative 2. Okay? And this brings up a good point. Sometimes kids get so into the elimination, and they just go right away and cancel out the 2's. I don't want you to cancel out the 2's. I want you to cancel out a x or a y. So ignore that. That doesn't matter. It's one of these. And one of them is really, really close. They're both 3y. But I don't want a positive 3y and a positive 3y because that gives me 6y. I want them to cancel. So one of them needs to be what? So how can I fix that? Times what? The whole thing. Which one? Doesn't matter. If you multiply the first one by a negative and your friend sitting next to you multiplies the second one by a negative, you'll get the same answer as long as neither one of you messes up. So I'm just going to pick one. I'm going to multiply the top one by a negative because if that's a positive 3y and that's a negative, it'll work for me. So that means that you kind of have a new equation to do. That just multiplies everything and changes it. And now watch. I'm putting a little squiggle through that line. I'm not putting a big one. You're going to see why in a minute. And now this is the equation that I want to add vertically like this. These cancel, which is awesome because that's kind of why I did it. And then I have 5x plus 4x is x. And this one works out great because I don't even have a coefficient to divide by. X is negative 4. Pretty painless. X is negative 4. So the rest of it's kind of the same, except there's some tips here, okay? If I were to take this negative 4, I have now 3 choices of where I can put it. I can put it here and here, which are essentially the opposite of each other. This equation, or this one. You can't go wrong. It doesn't matter. Later, I'm going to show you why you might want to use the crossed out equation, but I'm just going to use this one. I'm just going to use 5 times x plus 3y equals negative 2, and for the sake of time, I am going to fly through this part of it because we got lots of other levels to show. 3y equals 18, and that's when your y becomes 6. Okay, this part right here is the same as we've been doing in substitution, and it's solving a 2-step equation that you should know how to do. So let's move on to level 3. A level 3 adds a little bit of difficulty into it, and you're going to notice why immediately as soon as you see it. 8x minus 4y equals negative 4. Everything looks good so far, but here I have 4y equals 3x plus 14. And right away, you should realize it's not ready to go. It's not in standard form. So guess what? You have a little extra legwork to do. Put it in standard form. And that shouldn't be a big deal. The only thing out of place is that 3x. It belongs on the other side, right? Okay? And more than ever this year, I don't know why, I am having kids just take that 3x and put it on the other side. And then they just put 3x plus 4y. And then it's wrong. Because if it's a positive 3x over here, it's not a positive 3x over here too. Because we're skipping steps and we're forgetting to do the inverse. Oh, so if it's a positive 3x over here, it's really a negative 3x here. Now, here's where you're at. You really want your equations to line up, one above the other, don't you? Okay? So I'm going to kind of rewrite this, and this is all on you if you want to keep it organized. So when I go to rewrite it, and I want it all to line up perfectly, I kind of had to do a little bit rewriting. Now this is where I need it to be. The y goes in the second spot, and would you look at that, how nice that worked out to be. So a lot of times after you get it in standard form, it'll be ready to go. It'll be a level 1. Sometimes it won't be. So now that you kind of gave yourself a nice little clean work area and lined them up, the y's cancel, and you have 5x equals 10, and from there you keep going. X is 2. So I fill in what I know, and then I look for the other one. Okay? Again, you can't go wrong with where you choose to put that 2. Okay? It's just a matter of one of them might be a little easier or harder than the other. Okay? So this might be the last one that I do just to kind of, so let's just use this one right here. So negative 3, I'm going to use this one, plus 4y equals 14. Negative 6 plus 4y equals 14. Add 6. That's going to give you 4y equals 20. And that's going to give you 5. Okay, level 3, we okay with it? So you just kind of have to get it in standard form. Okay, so we're going to say level 3 means rearrange to get into standard form. Okay, and it might be both that are out of standard form. It might be one where you have everything over here, a 3x, a 4y, a plus 7, and then an equals 0. Well, what's the only thing out of place? The 7. So subtract it from both sides, and then you'll have a negative 7 on the other side, okay? Are we good with level 3? We've got 2 more levels to go. All right, level 4. This is where it starts to get a little bit tricky. But if you understood level 2 and what we needed to do, so let's look at this. 6x plus 5y equals 19. And 2x plus 3y equals 5. Excuse me. So right away you notice, just multiplying by a negative isn't going to cut it. It's going to be one thing I need to do. So the first thing you have to do is decide which one you want to get rid of. You want to eliminate the x's, or do you want to eliminate the y's? And I'm not telling you which one you have to do. I'm telling you which one's a little bit easier. Which one's a little bit easier, Alex? The x's. Why? Awesome. He said because 2 is a factor of 6, basically. So all I need to do to turn that 2 into a negative 6 is multiply everything by a. Okay? Finding that number in red is probably one of the most important yet difficult concepts of elimination. Kids get to this point, they can do level 1s and 2s and 3s, but when they get to these problems, they don't know what to multiply it by. You have to say to yourself, well, what would cancel a positive 6x? You know what would? A negative 6x. Okay, that's not a negative 6x. It's a 2x. What do I need to do to get it to be a negative 6x? Are you with me? So it's kind of like saying this. It's the missing factor. 2x times what would make that a negative 6x. Well, you know that has to be a negative 3, right? That's the thought process you're going to use to find that. And just because it's right underneath it, I'm not going to recopy this. I'm just going to keep it. Multiply everything in there. I'm going to put a little squiggle through that. And that's up to you. If that bothers you being there, you can just ignore it, because these are the two equations that I really want to use, okay? So now I'm good to go. The x's cancel, and then the rest is kind of a piece of cake from there. Negative 9y, or negative 4y equals positive 4. And then we have that our y value is negative 1. And now I'm going to say something new. Okay? You have three choices of where you can put that negative 1. You can put it here, here, or here. And kind of like last lesson in substitution, remember how I said, oh, that's an old equation. You want the updated, new, improved version. This time you probably really don't. Because would you rather work with 2s and 3s and 5s? Or 6s and 9s and 15s? I mean, if you're doing it in a calculator, no big deal, right? But these numbers are actually easier than these numbers. So today, for elimination, I might want to use that equation. That's kind of why I didn't scratch it all the way out. I mean, you could use that one just as easy, right? So I'm actually going to put the negative 1 right back in the original equation. But, again, this is me trying to help save you some time. You won't get it wrong if you use either of the other two. 2x, positive time. I'm just going to put a minus 3. You know why? Because a positive times a negative. And then I'm going to add 3 to get 8. And then 2x is going to equal 8, which means your x is 4. Are you good with level 4? I have one more to show you, and you can probably guess what it's going to look like. Okay? So level 5 looks like this. It looks like 4x plus 5y equals 35. Negative 3x plus 2y equals negative 9. So, I shouldn't, if you've been with me for level 1, 2, 3, and 4, I shouldn't need to tell you what you have to do. Like, instinct should kick in and you go, oh, if I need to cancel the x's, then I need to multiply not one equation, but both by something. So the hardest part, because I already was nice to you, I put them in standard form for you, but I look at this and 3 isn't a factor of 4 and 2 isn't a factor of 5. Like, all I had to do here is multiply by negative 3. So you have a decision to make. Do you want to eliminate the x's or the y's? There's one that stands out as a little bit easier than the other. Which one? I would actually think the what? The x's. Why would, I mean, and that's just my opinion. That might be your opinion, but why are the x's maybe a little bit easier? It could, but that's not the reason why I feel like it's a little bit easier. Yeah, one of them's already negative, one of them's already positive, right? That's a big factor in this, guys. One of them's already negative, one of them's already positive, great. Now if I could just make them both positive 12 and a negative 12, I'd be good. So let's do that. What am I going to need to multiply the first equation by to make that a positive 12? Just 3. What am I going to need to multiply the bottom equation by to get it to be a negative 12? A positive 4. And then you have two brand new spanking new equations, and you say 12x plus 15y equals 105, and negative 12x plus 8y equals negative 36. And I have some pretty big numbers, but that's okay. We're good to go because these cancel. 23y is equal to 69, and when I divide by 23, I get a y value of 3. Okay, and I want to just leave this right here for right now. Okay, and then if I put that 3 in, don't go all the way back. Like, here's the deal. Don't use these equations to put the 3 in. Use one of these other ones. I'm going to use this one. I don't even want to deal with 35. I want to be able to do it all in my head. So I'm going to take negative 3x plus 2 times the y, which we just learned is 3. Negative 3x plus 6 equals negative 9. Minus 6, negative 3x equals negative 15. So my x works out to be 5. Now, I want to show you something. What if somebody didn't want to cancel out the x's and instead said, I'd rather cancel out the y's? So this is if we eliminate the x, what would I need to do to the problem if I wanted to eliminate the y's? So let's take 4x plus 5y equals 35, and I want to just point out one thing and then we'll be done. All right, you want to eliminate the y's? Go for it. What would you need to multiply each by, though? And there's two different answers.
The top equation you could do just multiply it by 2.
Mm-hmm.
And the bottom equation by -5.
Good. That's one correct way. She said, hey, I want them to be a positive 10 and a negative 10. Multiply this by positive 2, but this one by negative 5. Anybody have another way that'll work? Because does it matter which one needs to be negative? So go ahead, Evan.
Oh, you said multiply something by -2.
Good. So he said, you can multiply this one by negative 2 and this one by positive 5. As long as one of them's negative, it doesn't matter. So if you're working with a partner and you're looking at their work and you go, you got to multiply this one by negative 5, they may have it. It might be just a different way they did it. So let's just go with positive 2, negative 5, as long as one of them is that. Now let me show you how that affects what your work looks like. You're going to get 8x plus 10y equals 70. Then you're going to get negative 15x minus 10y equals positive 45. And then those are gone like you wanted them to be. Sorry, that should also be, yeah, that's all positive and that's all negative. That's right? Yeah, because it's not matching up to my answer key here. That's good. Okay, so then what's that going to give you? Okay, never mind. That's why. Why didn't somebody catch me? I knew it was supposed to be 23x. That's why I was like, because negative times negative is positive. 23x now, we're getting there. 23x is going to equal what? 115. And if you divide, guess what you get? 5. So when I canceled the x's here, I found my y first. When I canceled my y's here, I found my x first. You'll get the same answer. It's just going a different direction. I have 2 more things to show you because there's always that thing called special cases, and then we're done. Okay, that's the time to leave, isn't it? Okay, how about this? 2x equals 3y minus 8, and negative 2x plus 3y equals negative 5. Well, first of all, I got to get it in standard form. You guys are awesome. We're almost done. So let's subtract this 3y from this side so that I can get it to this side. And that gives me this new equation just rewritten as 2x minus 3y. The negative 8 was fine where it was. What is going to go on here? Yeah. The goal is to eliminate one of them. But every now and then, like 5 to 10% of the time, both of them get eliminated, and no matter what you can do, you can't help it. They both are gone. We learned this already. Do you remember what this does? When the variables cancel, we learned it in Unit 2-3, I believe, in like October. What's left over here? Nothing. What's left over here? Does 0 really equal negative 13? No, it does not. So when your variables cancel and you are left with a false statement, false is not your answer. What does false mean? It means the answer you're going to put on your paper is no solution. Hey, let's not forget what we're doing. We're talking about systems of equations. What does systems of equations mean? No solution means what? Where do they meet? Nowhere. They're parallel. You don't have to write the word parallel. You don't have to write the word false. I really just want you to say no solution. But I want you to know why it's no solution. Because they're parallel. If I were to solve both of these for y, their slopes would be what? The same. Okay? So then somebody said, well, how would you get infinitely many? And I said, instead of a negative 8, that would be a positive 5. Right? Because then what's a negative 5 and a positive 5? 0. So not only do the x and y's cancel, so do the constants. And 0 does equal 0. Yeah, that's true. So when they cancel and you get a true statement, You don't write true. What does true mean in terms of the solution? I should have written that in red. Infinitely many is the important part. What does that really mean for systems of equations on a graph? What does infinitely many? It means they're the same line. Yep, that's what that means. Okay, are you starting to kind of wrap your head around systems of equations? There's lots of different ways to solve them. We just learned elimination. Okay, get rid of